High energy costs and the growing impact of climate change mean sustainable energy is a hot topic. Offshore wind power is key to helping the UK achieve its CO2 emissions targets and provide affordable, efficient energy. Our £7.7 million collaborative research project is focused on ways to improve many aspects of offshore wind energy production. The mechanical power produced by the rotation of the blades drives the rotor of the generator, which has attached to it several powerful, permanent magnets. The motion of the magnets past stationary coils in the stator creates a voltage, and, therefore, an electrical current. This electrical power passes through a converter and then a transformer to ensure the voltage levels match that of the national grid system. The electrical power then travels through cables under the sea to an onshore facility, which is connected directly to the national grid. We have developed some crucial improvements to the direct drive generator, that is, a turbine without a gearbox, which is very beneficial because it is often the most vulnerable part of the turbine and can require expensive maintenance and repairs. Our innovative developments make the generator much more reliable, efficient, lighter and cheaper. And that means we can produce a lot more energy from the same number of turbines. In addition, we have created exciting and innovative ways to monitor the health of many components of the wind turbine, to provide predictions of issues and faults that need to be addressed. We can monitor the health of individual elements on each turbine, such as the blades and the oil-lubricated components, or the performance of the wind farm as a whole. This is important because when wind turbines aren't working, the electricity they would normally produce may have to come from more expensive, less sustainable sources. Advanced notice of possible failures can drastically reduce the amount of time a turbine is out of action. Our research has also developed new ways to design and manufacture the key components of the turbine, to improve their performance and increase their reliability. We have been using fibre optic sensors to monitor the casting of the blades, to help improve quality, reduce waste, and speed up the introduction of new designs. We have also developed methods to design blades with optimum strength, while minimising the use of materials. Finally, the research has improved our understanding of the interaction between cables and the seabed, resulting in ways to assess the appropriate burial depth of cables to ensure reliability and prevent damage. This project has been a real team effort. We couldn't have done it without the support of our project partners and experts. Over 20 nations have been represented on this project. So, what are the benefits? Our research will reduce the cost of producing offshore wind energy, making it more reliable and sustainable. This means the UK will benefit from affordable, sustainable energy with reduced reliance on non-renewable sources. But that isn't the end of the journey. Another key outcome of the project has been identifying why further research and development is essential. Continued funding is needed to develop new innovations that can ensure offshore wind power becomes even more efficient and affordable, helping us to meet a greater percentage of our growing energy needs in a carbon-free, sustainable way.